Yeah, hi everybody. Hello, dear fx-Calc user community. Today we'd like to focus on our second session of the fx-Calc introduction, and the topic for today is inbuilt functions. It's not a big deal, but maybe yeah, a bit different from what you would expect from a normal calculator. So basically, the input of any numbers and operators is again being performed by using those buttons on the right hand side. And our focus today is on inbuilt functions here on left hand side. And yeah, bottom line, I'd like to explain a little bit more about it, because if we take, for instance, a value of 30, yeah, and would like to know what the sinus of 30 would be, then we simply have to click on the sinus button. But what happens now is that it extends the editor box with a function call, and that's the function call for the sinus function, simply speaking. Yeah, so bottom line, those buttons here will not apply a certain function to a value which is just being displayed or used in this user interface. It simply puts a function call into this text box here, and that's it. Yeah, so for the moment it calculates nothing, yeah, because the argument of the sinus function call is empty. And basically those function calls have always the same structure. Yeah, we start with the function name, yeah, followed by brackets, and the argument needs to be put into those brackets. Yeah, so in this case 30. Yeah, so place the cursor in this into the brackets and push the buttons for 3 and 0. And yeah, well, it immediately calculates what we'd like to see here. And that's the way how it works. Yeah, it's not the way how a normal calculator would work, where you push a button and it's making use of whatever displayed value and is then calculating the function based on this value as an argument. It's here the other way around, that a function call is being used to calculate a specific expression. Yeah, and that's very much the way how you would, for instance, enter a mathematical expression into BASIC. I know that may sound a bit ancient, but well, that's the way how you would place mathematical expressions in whatever computer language. And it's maybe a bit different for power functions. Yeah, but what we can do here is to extend this expression, yeah, by, let's say, a square function for and this then as a square. Yeah, and that's a bit different because it's not applying a function call but an operator to the expression, and this operator is basically used for any power function. So what we could do here is to extend it further, yeah, by plus, I don't know, 3, and then this one here again, and 3, yeah, 3 power 3, which is 27, and so on. Yeah, so any power functions are usually entered by using this operator here in order to yeah, place those calculations into your expression. And if you look at the others, yeah, we always or almost work based on a function call, yeah, just like ln from something, 8, let's say, or let's go further with square root, yeah, of something, or that's wrong, or whatever logarithm, decadic logarithm, for instance, here. Yeah. So it's almost that a function call is being added, yeah, and in some cases just specifically like for the power functions, it's this little operator here which is being inserted into the text window to make it working. And there's maybe one interesting question about square roots, because apart from square roots, you could have as well a third root, a fourth root, a fifth root, whatever you can imagine. So let's clear our editor window and for instance, let's think about the fifth root of I don't know, 625, just to say something about it. So that's being calculated by, again, using the power function, but in a specific way, because if you would formulate the power with the reverse exponent, so in brackets, then here 1 divided by 5, that would be the fifth root of this specific number of 625. And what we could do here is to say we calculate 5 power 5 and take the fifth root of this. To make it a bit more readable, I put it in brackets. So just to provide you with some evidence that this way of calculating it is exactly working. So that's the fifth root. That would be the basis for this root calculation. And I have prepared a little explanation for this. Simply speaking, what we are looking for in this case is really y in this equation. So we have our argument, which is being used, and what we are looking for is y. We know which exponent is being used, so that's the third, fourth, fifth, whatever kind of root, and to resolve this expression, you simply need to power this expression by the reverse exponent. That's exactly this operation here, which has to be applied. Because at the end it gets to the point where this multiplication of the both exponents leads to an exponent of 1, and this exactly provides you y as result. That's exactly the result that you are looking for. So bottom line, any root can be created by exactly using this kind of expression here. And just to repeat the exercise, let's for instance look at 27, and here in this case then the third root, and I take the keyboard here in this case. So 27 third root is 3, 64 is 4, and so on. So that's exactly the reason why we only find the square root as a very common function in our buttons in here, but the others can easily create it by applying this mechanism to your calculation expression. So the last final thing that I want to explain about inbuilt functions is, of course, that you need to have to care about the argument range, for instance, for the trigonometric functions. Currently, it's using degree. So the usual period is from 0 to 360 degree, but it could be as well radian, which is from 0 to 2p. And bottom line, all this is then again explained during your calculation with those little hints which will appear when your mouse cursor is moving over one of those buttons and so on. So that's all about inbuilt functions. What I'd like to focus on for a moment is, of course, that you have this little area on the left hand side here, which allows you to define sum and product calculations. But for the moment, I'd like to postpone this a little bit, yeah, because prior to explaining the inbuild functions, I would then like to focus on self-defined functions in our next session, because with the understanding of self-defined functions, it's much easier for you to understand the logic behind sum and product calculation. So that's it for today. I hope you enjoyed this short introduction session, and as every time, yeah, if you have questions or hints, just use this little mail button here and send me your feedback. Don't forget to put your mail address here, otherwise I cannot answer this. Or the other way is, of course, to go onto the website and open the forum, which allows you as well to place your topics and to get answers on certain questions. Yeah, thank you very much for today, and yeah, see you next time in our session about self-defined functions. Take care and bye-bye.